So let's do Learning Objective 2.8a and compare residuals of two models and determine a better model. Now we've talked about residuals before, but let's talk about what deviation is. Another word for deviation is the amount of error that we might see in a model. And how much error a model has is what we observed from the scatter plot minus the predicted amount that will come from the model that we computed. Now, a more common word for the deviation or the error is the word residual. So now let's take a look at this scatter plot right here, where we have 5 different ordered pairs or 5 different observations. In particular, we're looking at the observation here when x is 9 and y is 5.22. So this x value, again, is 9. The 5.22, because it's the ordered pair, is our observation. Now, when x is 9, if we go up and we hit the green line, this will actually show what our prediction is for x of 9. Now, what they've done is they have taken all of the x values from the scatter plot, and they're going to use those exact same x values this time, but what they're going to graph this time on the y-axis is going to be the amount of error or the residual associated with that value. So when x is 9, we can tell there is a positive residual. It looks like the residual amount is from about a little over 5 to a little over 4, so maybe there's about a 1.0 amount of error. Well, if you come to this residual plot, which is just a plot of all the errors for these 5 ordered pairs, when x was 9, we look at 9 and we go up, and the residual is roughly at 1. It's actually, right here again is the x value. This right here is the residual value, which they're saying is 0.96. So this here is a good question. They want to know what is the predicted value from this graph when x is 9. Well, remember the formula. Observed minus predicted equals residual. Well, they just told us here the residual is 0.96. The observation is 5.22. So 5.22 is that. I don't know the prediction quite yet, but I know the residual is 0.96. Can I find that amount? Sure. I can take the 5.22 and subtract from it the 0.96, and if I do that, the predicted amount will be 4.26. Well, if you look back on this graph, when x is 9, we hit the green line right about there, which seems reasonable that it could be about 4.26. Now, once you've taken all the x values related to your scatter plot and looked at their error and graphed it and made a residual plot, you need to know what you're looking for in the residual plots. Well, the residual plots, you want them to fall within a horizontal band centered around 0. So if you look down below, letter A here is a nice residual plot. The error that you see, this is all pictures of the error in the model. It's evenly dispersed out and it's not biased towards one particular spot. Now, how do you know if a better model can be found? Well, number 1 here says if your residual plot is positive or negative on both ends. And what that means is if you look at graph B here, the residual plot is positive on this end and positive on this end. It's actually making a shape. It looks like a parabola. I do not want the residual plot to make any recognizable shape other than a horizontal band. So this is bad. The other pattern would be if it made kind of this negative parabola. We don't want to see the patterns. The other thing is that a residual plot, when it increases or decreases like a funnel, as we see here in picture letter C, that's not good. We don't want to see a pattern like that. Basically, it's just showing there's a lot of air on the up front and then the air minimizes out. But still, it's a pattern and we don't want that. So when you're doing modeling of scatter plots, trying to figure out if it's a linear, quadratic, or exponential model, there are really 5 things you should consider when building that data. The first is you want to make sure to build a model from theory if possible. You just don't want to make something up. For example, if you're making a scatter plot on, I've said this before, you know, how many Snicker bars did you have this morning and the grade you got on the test? That's not theory-based. You're just kind of guessing that there may be some connection, and it really doesn't make logical sense. Number 2 is going to say, first thing you do is to plot the data on a scatter plot and draw the model on the same graph. So you're going to go in there, come up with the model, and see how well the equation model matches the scatter plot. Once you've done that, you should graph the residuals. If they don't fall within a narrow horizontal band around the x-axis, or if there is a pattern, you really want to change your theory that you're using or look at a better model. For example, let's say you were using the Snicker bars, would show that your grades would be better. Maybe you should use a connection. How many glasses of milk did you have this morning? In terms of would that make your grades better? Change the theory. That still may not be a very good theory, but it's saying we need to look for either a different model, like linear or quadratic, or you just need to change the data altogether and do a better analysis of some better data. The other thing, number 4, is use the correlation coefficient to check if a linear model is appropriate. Remember the correlation coefficient. When you do a linear regression, it kicks out and it says R equals. So it might be like R equals 0.7. And this number is from -1 to +1. The key here, though, is that our number on the calculator is only valid for lines. It does not work for exponentials or quadratics. The last thing they're going to tell you is be aware of the model's ability to interpolate and extrapolate. Remember, interpolate means if you have your data in your scatter plot and all of your x values range from 1 to 10, that if you want to make a prediction on x, if x is 15, that's outside of your data range. That means you're extrapolating if you're outside of your data range. But if you're, again, your x's go from 1 to 10 and you want to make a prediction about if x is 5, what would you get? That's considered interpolation. And in a conclusion on this, sometimes there is just no good model. What type of model here do you think would best predict this scenario? This is a trend from the stock market. If you analyzed it, you might think linear, exponential, or parabolic. But really what happens when you look at this model, it's going to be hard due to changes in the market that happen. These changes happen every minute, every day, or every month. So if you have data that's very volatile and is not stable and changes dramatically as this right here, if you look at the stock market when they zoom in on the data, it's just not going to be smart to try to make any one of these 3 models to make as your predictor.